So now we can do the entire thing again for fragment shader, or we could consider factoring this a little bit. So what we want to do is we want to go for this. We want to create a private here, which is GLUint. We want to call it load shader. It's going to take a GLEnum, there we go, which is the type of shader, and we're going to take const standard string, which will be the file. Load this from, and I can see we need to include. Oh, I am so terrible at spelling include today. We are gonna include string here, getting that running, so that rather than doing all of this, hopefully just say load shader, GL vertex shader from shaders / base dot vert. Then we of course quickly need to implement this wonderful GLES renderer load shader. So this is going to be a GLUint return. So we create a shader of the pass type. We read the given file, we compile it, and we set the source, and then we compile it. Of course, this is not vShader. This is the return value or whatever shader this is, and then we just return. Could of course just quickly refactor rename shader. So apart from that, we also need a fragment shader. So GL fragment shader. Let's just quickly create that one as well. So a new shader, base.frag. So this is a nice simple little fragment shader. It basically just says the color of this pixel is red. I can live with that shader. So we're going to go with that initially. Let's load that up. So that gives us our vertex and fragment shaders. Yeah, let's just make sure we don't get any errors. Let's try that instead. There we go, and refresh. No OpenGL or WebGL errors. So now we have our two shaders loaded. We need to link them together to make our shader program. So to do that, we first have to create our shader program. GL create program. Sometimes the names are nicely simple to sort of figure out what they are. So with the program created, what we want to do is we want to attach pair shader. So we give it the program, and then we give it the shader. So we want to attach the vertex shader, and we want to attach the fragment shader. And then with that done, we can link this together. So that should essentially load our shaders, link them together, and have them ready for use. And no errors. Just so you guys can see, you see? No errors. Wonderful stuff. So now we are going to try and render something. Now this is where it gets a little bit more interesting. Again, nothing like a quick reference card. So what we want to do is we are going to try and push some pixels, or not some pixels, some vertices. So let's see if I can. This is the shading language, which is not what I wanted, because I vaguely remember there being something about buffer objects. Buffer objects. So, buffer objects hold vertex array data or indices in high-performance server memory, aka GPU memory, which is pretty much what we want. So we can generate a serial of buffers, we can delete them, we can bind either as an array or element array buffer, then we can buffer data into it. So this would be putting data into it. Then we have sort of like these usage kinds, which are hints, saying how are we going to use this data? Is it just going to be permanent static data, in which case it's good to put in VRAM on the graphics card? Are we going to be streaming and changing it every scene, in which case it's kind of wasted to store it in the RAM on the graphics card? Or do we not really know and want the driver to sort of guess? Then we can do this dynamic draw thing. So yeah, I guess that is what we want to do. Then we can do vertex arrays over here, which is what we're going to be doing in a moment, to then pass the actual data, or say use this data as vertices, because this is just sort of like dumb data. It doesn't really know what we're doing with. And then this is more sort of, okay, now actually use this data as vertices. I kind of have this feeling that I'm missing something here. Something about the format of the vertices. Ah, wait, here it is. Oh, what the hell, we'll just go for it. So we're going to try and create a buffer. This will be a buffer of GL floats. So verts. We're going to see if we can't manage to draw a little triangle. See if I remember the coordinate system correctly. So if we go for minus 1.5 and minus 1 minus 0.5, 0 and 1. Ah, the joy of homogeneous coordinates. So here, 2, here. This should give us something vaguely triangular. So what we need to do is we need to have a GLUint buffer. Then we are going to bind said buffer. Are we really? I don't think yeah, this is, yeah, we need to bind it. So we go for GL bind buffer. Our target is that this is going to be an array buffer. And, oh, sorry, we need to first generate the buffers. So, start with GL gen buffers. We're going to generate one buffer, and we're going to store it in buff. Then we're going to bind that buffer. Then we are going to transfer data to it. This is, again, GL array buffer. We are going to transfer. This is gonna be size of verts times size of GL float bytes long. Then the actual data are our vertices here, and we are going to be doing static drawing with these. GL static draw. Hopefully. Let's see if OpenGL complains too much about that. I can't hit the run button. No errors, so maybe it's working, maybe it's not working. Nobody really knows. So apparently it helps if I show the code. I kind of forgot that I was doing the documentation. So, switched over. So what we just did was we declared, or we sort of went for the vertices here. We created the buffer. Then we actually asked for the buffer, find the buffer to our array, and then we tried to transfer data into it. So far, so good. Now, this is where it gets interesting, and we'll see if I know just vaguely what I'm doing. So I'm going to switch it back to documentation, because what we're going to do now is we're going to do an attribute pointer, and very interesting here is if an array buffer is bound, which we've just done, the attribute will be read from the bound buffer, and pointer is treated as an offset within the buffer. So all we need to do is we need to go for the vertex attribute pointer, and that will tell us what that is, and then we'll see what happens from there. I don't know yet. Might go horribly, horribly wrong. I'm also wondering sort of about the index here, because I have a vague idea that I need to get the... Yeah, exactly, here we go. I need to get the vertex attributes because I'm going to switch back to code for a moment. Because we have these, in our vertex shader, we have an attribute which is the actual vertex that we're being passed in. So we have to get sort of a pointer or reference to that. Dum. Now I'm sort of looking to see if there's somewhere... here we go. Find attribute location. This is what I was kind of looking for. And get attribute location. Okay, here we go. Because what we need to do is we get the attribute location. This is at least what I vaguely remember. Which then we passes the index here. We tell it the size, we tell it the type, and then we tell sort of the stride. I certainly hope so. How bad can it... Yeah, we'll go for that. So, back to code. So having done all of this, we are gonna try and see if we can't do glint, which is big GL small int, vertex location, GL get attrib location. So our program is the one we have here, and the name that we're looking for is vertex. Okay. From that, I'm hoping this is right. Otherwise, Google will help. Vertex attrib pointer. So the vertex attribute we want to write to is the vertex location. Then the size is, I guess, 12. We have 12 elements. Type is GL float. Normalized, probably not. Stride, 1. And pointer is treated as an offset within, so 0. See how bad this goes. Try reloading. Yay! GL error. So, time to look up what that error is. Bad value. So now you get the wonderful, wonderful, so exciting part of me searching for answers to figure out what the hell is wrong. So we're going to start here with, because I'm guessing it's GL vertex attribute pointer something's wrong with. Index is the generic vertex attribute to be modified. Should be correct. Size specifies number of the number of components. Yeah, 12 is a bad value then. So this should be 4 instead, because we have 4 components per attribute, 4 components of the position. Great. Normalized specifies whether fixed point data values should be normalized or converted directly as fixed point values when they are accessed. It's not fixed point. Anyways, it should, if anything, be the sort of OpenGL or WebGL constants. Stride. Stride is 0. We are tightly packed. Well, let's give this a go. No errors this time. That's always an improvement. So, with that out of the way, we now need to tell it to draw, which should be the draw arrays. So, GL draw arrays. Mode, we are going to be asking it to draw GL triangles. The number, I'm guessing is 3. Oh, sorry, first one, 0, number 3. 3, not 2, 3. Well, this will either go terribly, terribly wrong or terribly, terribly well. Nobody really knows. GL error 1282 this time. So, GL error 1282. Let's try that one. Is invalid operation. So, GL to array. Specifies the starting. Okay, enable specifies what kind of primitives to render, which should be fine. Specifies starting indices and number of indices. To pre-specify separate arrays of indices, normals, and colors, and use them to construct a sequence of primitives. So I'm guessing something like GL enable vertex attributes array would probably be a good idea. Oh, yeah, that's probably what we want to do. So GL enable vertex attribute array. And I would like to enable the vertex location one. I'm just going to print out GL error a couple of places just to make sure I know where it goes wrong, because this is not going to work. At least that's my guess at this point in time. Yeah, we're still failing. Okay. Let's draw arrays, and it... I forget what our error was. Invalid operation. Nay, Stack Overflow. GL invalid operation is generated if a non-zero buffer object name is bound to an enabled array or to the GL draw indirect buffer binding, and the buffer object's data store is currently mapped. So I probably need to unmap something somewhere. Oh, there's a lot of possibilities. But I don't have a transform feedback in use. So the question is, let's just see the documentation for GL find buffer. I want it for GL yes 2. So value 0 is reserved. Instead, buffer set to 0 effectively unbinds any buffer object previously bound and restores client memory usage for that buffer object target. So, back to the code. So if we go and, after we've set up the attribute pointer here, we should be able to unbind the buffer, then enable that and draw the arrays. Oh, I'm hoping so. See what happens. Nope. I'm sure this was all what you were expecting. Lots of figuring out why stuff isn't working. Hmm. Oh, this is DGL spec. That's why it looks wrong. So, buffer objects, array buffer, static draw. The alternative is to try this the really, really simple way, where we start by not going through all of this, but instead we just quickly find it. We don't have a vertex buffer active right now, so we should be able to just use the pointer directly. Oh, I need to grab the attribute location. So let's see if we can do that. No. It definitely did not like that, but it's giving us an error at a different point in time, which might help us sort of figure out what's going on here. So this one corresponds to this state here, where we're failing. So vertex attribute pointer. So the normalize is sort of okay. So if set to true, normalized indicates that the values stored in an integer format are to be mapped to the range -1 to 1 for signed values, or 0 to 1 for unsigned values when they are accessed and converted to floating point. Otherwise, values will be converted to floats directly without normalization. I don't care about that. I'm not using integers. So where did this go wrong? Okay. Time to go looking for an example. So we have vertex structure, x, y, z, normals, texture coordinates. Create all these vertices, generate a buffer, bind it, buffer the data. Seems very similar to this part up here. Now we do indices, do it that way. Okay, interestingly, enable client state, GL vertex array. And then we do a vertex pointer, which is, this is sort of an old school, yeah, it describes legacy OpenGL. Thing here is that sort of like these default things don't exist in OpenGL ES, where you just access the vertex attributes more directly. That said, I would guess that this is the enable vertex array attribute here. So I might need to actually move that up a little bit. we're going to transition back to the code here. We're going to undo this little experiment, go back to this. So what we want to do is we probably want to enable this already here. We're also using some sort of interesting buffer offset. Let's just try and see what's still an invalid operation.